We're going to teach you how to get the most out of the advanced mode of the IPVM camera calculator. To start with, notice that there are 4 physical sections of the calculator. Up top is going to be your inputs or your key parameters. On the lower left-hand side is going to be a chart that displays the relationships of the object, the camera, the angle, etc. On the center right-hand side is going to be sample scenes and field of views. And then on the bottom right-hand side is going to be a pixels per foot preview, both with a day image and then a night image as well to give you that comparison. So let's start up top in the top panel. You'll see the very first thing under the IPVM logo is camera resolution. So you can pick any camera resolutions going from VGA up to 12 megapixel. So we've defaulted to 1080p HD, but you can easily switch to 12 megapixel. Now, when I switch to 12 megapixel, I want you to notice something. Specifically, look at the pixels per foot number all the way down in this bottom here, and the image as well, right? So we're at HD 1080p, and for this field of view, it's saying it's 10 pixels per foot. We're going to switch from 1080p to 12 megapixels, and notice what happens. Now we have 22 pixels per foot. So our pixels per foot, right, jumped by 120%, and the image change as well. So it shows us what the difference might be. So again, I'll go back to 1080p HD, and then on the bottom, notice that the image, right, clearly the pixels per foot is lower, and it gives you a preview of what that's going to look like with the lower number of pixels per foot. And that's simply by changing the resolution. There are some other controls here, imager size. So if you're aware of which imager size you're using, the most common one that's used in surveillance is 1/3. 1/2.7 is getting more commonplace with some HD cameras, but you can always pick whatever imager size you want, and the focal length. So if you want a 9mm lens, you can put that in. Alternatively, imager size and focal length combine to create the angle of view. So you can either input it there, or if you know specifically, say, listen, I want an 80-degree angle of view, it'll then dynamically figure out, okay, you want an 80-degree angle of view. If the imager size stays at 1/3, then the focal length has to be 2.9 millimeters. Then on the final column, on the right-hand side up top, you'll see distance to object, and that's just simply how far is the target, the person, the vehicle, etc., away from the camera. Here we have it 89 feet. We could always change it. Let's say we want it to go 100 feet. You'll notice that when you update the distance to object, the chart changes as well. So I'm going to type in, go from 100 to 30, and you'll see here that the graph moved. And I'll put this over here to 60 just to show you it moving again. So the graph moved out to visually represent that the camera is now farther away from the target. And then the horizontal field of view is the width at the point of where your target is. So, we could, of course, make that narrower here. And so now we have a narrower field of view. And then pixels per foot, you can actually enter in what pixel per foot target you want. So you might say, like, listen, 38 pixels per foot isn't enough for me. I want 50 pixels per foot. And at 50 pixels per foot, it would automatically tell you, listen, if you want 50 pixels per foot, given the angle of view you chose, the target can only be 23 feet away. Now, there are other things that you can do to further experiment. So I want to show you right beneath this is the scenes. You'll notice that over here, so it'll say, I can control this, and I'm going to just sort of drag it up, and I'm going to say, okay, this is a 79-degree field of view, and it's here on our entrance scene. You can grab, or you can use either one of these controls. You can go up, or you can just drag the lines. So now I'm going to like 106 degrees, and I can adjust a little bit further, figure out, okay, is this how wide I really want it to be? If the object's 23 feet away, how's that going to look? So maybe you say, listen, in this scene, it's not really 23 feet away. I'm just going to say the distance to object is only 10 feet. And so now you can see that keeping the field of view the same, that 106 degrees, 10 feet away, you're going to get 71 pixels per foot. So you're going to get quite a high pixel density. Again, you could just go back and say, listen, you know what? Maybe I'll just go for a 720p camera. You can go over here, and we can switch it over 720p. And now you'll see you went from like 71 to 47 pixels per foot. So you can instantly see that trade-off. You also aspect ratio, same thing. So, we've been using the 16 by 9 for the HD resolutions. We go to 1.3 megapixels. So let me click over here, and now you'll see basically it'll show you the broader aspect ratio. Now you might be saying, like, listen, I'm not interested in doing an entrance right now. Well, great. We've got a number of other scenes. So let's flip and do the opposite. Let's go outside and let's go to an intersection. And so we can replicate the same thing here. I can drag this around and say, like, okay, this is 106 degrees. And I might say, you know what? I actually need to get both of these sides. So I'm going to, again, go to my chart, and I'm going to just drag it a little wider and say, what do I got with 127 degrees? Okay, is this 127 degrees enough? Now, distance to object is still at 10 foot. Now, 10 foot probably in a scene like this is just right over there, right? He says, listen, if I need to go an intersection, I probably need to go like 80 feet. So I'm going to go and type in here 80 feet. So we've kept our angle of view the same, but now what we see here is that you're only getting 4 pixels per foot for a subject who's 80 feet away. But now we only have a 1.3 megapixel camera, so we could try something else. So, maybe we jump up to 3 megapixel. So we're at 4 pixels per foot. Let's take a look at what happens when we go to 3 megapixel. All right, 3 megapixel, we go to 6 pixels per foot. Not really going to make a big difference. What if we tried to make the field of view a little bit narrower? So let's try that a little bit. Let's go to let's try it like at around 100 degrees. So then the question is, can we live with 100 degrees? Do you want to get more of this side? Do we want to get more of that side? Do you want to get it in the dead center, right? We can make these decisions. You'll see just by bringing the field of view down, we've increased from 6 pixels per foot to 11 pixels per foot. So it got significant more detail. Clearly, you still can't see faces, but you could dynamically try different things. So, we might want to say to us, let's narrow it down even further. And as we narrow it down, right, let's say, you know what, listen, I need to get 40 pixels per foot 80 feet away. So I'm going to keep on just sort of drawing this in. Keep on going. And what are we looking at here? So it's telling us that we need to get a field of view of 35 degrees to get 40 pixels per foot. So that shows us the trade-off. We might try other cameras. Let me see, let's go to 5 megapixel. All right, at 5 megapixel, we're up to 50 pixels per foot. Maybe we can make this a little bit wider, right? So, okay, now we're at 59 degrees, 5 megapixel camera. Now we're seeing the trade-offs of these various resolution, angle of views, etc. Another thing that's really important to look at is at the bottom right-hand side, we have a night preview. And you should recall and emphasize that night images are always worse than day images. It's just, then this is, we did real tests for this. This is not sort of theoretical. This is a parking lot scene, kind of your typical parking lot scene. I'm going to zoom, I'm going to go a little bit closer so we get something like 40 pixels per foot. All right, so you can see here at 40 pixels per foot, you can sort of barely somewhat make out the person's face, and you can clearly make out the license plate. But you look at night, and this is in a parking lot, even with sort of, lighting in the parking lot, and you really can't make out that face, and the characters on the license plate are really tough. But that's what's good about using this calculator is you can see the trade-offs between different scenes and different times of day. So we showed you the entrance. We just showed you here, we're looking at the intersection. We also have a lobby. So if you're interested in looking at a lobby, we can control it over here and say, okay, you know what? Can I see this whole lobby? Make this a little bit wider. So, maybe I need like a 75-degree field of view. And then, am I really 56 feet away? No, I probably don't need 50. I'm not probably 56 feet in this sort of lobby area. Let me bring it down to 34 feet. So 34 feet, 5 megapixel camera. I'm getting 48 pixels per foot over a 53 foot wide field of view. That's pretty good, and that's over at 75 degrees. So that would be a 3.1 millimeter lens over a 1/3 inch imager. And that gives you a good sense of how you can pull this all together. Anything else to look at? So we looked at all the scenes. You can change, here's the parking lot scene just so you can see as another example. Again, you can control that as well. So that gives you a sense of the scenes. We also have a conference room scene for more of a traditional, indoor scene as well. That we can control this and take a look at basically how it would look in sort of an office environment. And then I would say, the most important thing is probably as we're showing you is on the graph side, how we're doing these controls, moving things up and down. You don't need to use this graph. You could always put things in yourself, like you can type things out. Personally, I've found that it's just sort of more easily dynamic to sort of move things in and out and look at how things are changing on the calculator themselves. There are a few other modes with the IPVM camera calculator. I just want to give you a look at them. And they're on the main calculator page. You'll see, like, for instance, you can calculate what camera resolution do you need. So you say, like, my horizontal field of view is 20 feet, and I want 50 pixels per foot. You're going to need one 720p camera for this. But let's say you had a 40-foot wide field of view. So now you would basically need a 3 megapixel, at least one 3 megapixel camera at least, and you can keep on doing. So let's say I need a 400-foot wide field of view. The calculator knows that, listen, you need a lot of pixels. So at this point, you're going to need 11 1080p cameras to do that. And then there are a few other modes that you can use, like, for instance, how far can this camera see? So you put in basically the angle and the resolution and your pixels per foot requirement. So let's say, and you could of course do this in advanced mode. This is sort of more of a simpler way. If I need 50 pixels per foot, and let's say, I'm an 80-degree field of view, with a 1080p camera, I can only go 23 feet. So this gives you a good sense of your limitations. Even if you go to 5 megapixel, you're only to 31 feet. For each of these modes, you certainly can do them in the advanced calculator. We've made some basic modes for those of you if you just want to do something specific. But this to us is the heart of it. I think you're going to get a lot of value out of experimenting with these different elements to see what's best for you, going and looking at the trade-offs between the various scenes, the fields of views, the distances, the pixels per foot, the width, etc. Thank you.